Hey, Math 123, what's up? In this video, we're going to take a bare bones approach to getting the computations done that we need to do in Excel for Project 2. If you'd like to see more detail and do almost all of the computations that you need to do in Excel, there is a more advanced video that you can watch. But again, this video is just the barest of bones. This is the kind of the bare minimum amount of work that you'll need to do in Excel. And the most basic way to get the job done. So we're going to avoid using any cell references, and we're only really going to do the computations that we need to in Excel. There's a few calculator computations that I'm going to do in Excel just because it's convenient to do them here for you. But in particular, what we're looking at here in the spreadsheet, the gold cells, these are the only ones that you absolutely need to do in Excel. The green ones, I've already filled in some information. If you want to see where this information came from, go watch the first 5 or 10 minutes of the other video, the more advanced video, where we go through the project description to find most of these values, as well as use the Bureau of Labor Statistics to find some income values. But we're going to go ahead and pretend that we've done all of the research that we need to get all of these values, and we're ready to start doing some computations. And again, we're just doing the basic computations that we have to do in Excel. For the monthly salary, again, this is not one that you have to do in Excel, but we're just going to go ahead and do it here. So the number's right in front of us and we can reference it throughout. We need to take our yearly salary, $83,390, and divide by 12. Again, that's something you can do on your calculator. For the high school graduate, we would take their monthly salary of $24,000 and divide by 12. And I guess you probably would round this value. Let's see, 694917. 6949.17. Okay, so that's the value that we're going to use for the monthly salary for the Ivy Tech grad, for yourself. All right, now in prompt number 3, writing prompt number 3, that's the first time where we actually need to use Excel to get some things done. We need to find a mortgage, and we need a monthly home payment. We want to find 20% of our monthly salary. So if you take 20%, and multiply by that monthly salary, times 6949.17. That'll give you a monthly home payment, so $1,389.83. And then for the high school grad, we're going to do the same thing. Take 20%. You guys don't know how hard it is not to do this with cell references. 20% of $2,000. And so the high school grad will spend $400 per month. All right, now we needed those values to find first for prompt number 3, the largest value of a 30-year mortgage that each of these two people can afford. Okay, and we want to use the FV function to do that. Sorry, the PV function. We want to use the PV function. The PV function is the one that we use for loans. FV is the one that we'll use later on for retirement savings. So we want to use the PV function equal to PV. Again, this is the first actual computation where we need Excel. We want to take our interest rate, 2.45%, and divide by 12 to get the monthly interest rate. The number of payments that we're going to make. I guess I don't have this written down here. This is a 30-year mortgage. It says right there, 30-year mortgage. So we're going to take 12 times 30. And then we need to enter in our payment as a negative number. So that would be negative 1389.83. All right, so there's the PV function to get the 30-year mortgage for myself. And we also use the PV function to find the 30-year mortgage for the high school grad. Again, taking the interest rate, 2.45%, and that's the APR, and dividing by 12 to get a monthly interest rate. The number of months, this is a 30-year mortgage, so 12 times 30. 30-year mortgage with monthly payments, that's why we're doing 12 times 30. And then the payment, that's where the high schooler is paying $400 a month. All right, so there's a 30-year mortgage for the high school grad. Now, when you go to write about these things, there's also some comparison computations that you'll need to do there. And notice that we skipped over the first two writing prompts. You don't need to use Excel for the first two writing prompts, but there are some computations that need to be done there, both for comparison and the second writing prompt, finding some income after raises. But since it doesn't have to be done in Excel, we're not doing that in this video. If you'd like to see those kinds of computations done, you should watch the more advanced Excel video. In writing prompt number 4, we need to find the value of a 15-year mortgage. What's the maximum amount that we could get for a 15-year mortgage if we're making the same monthly payment? The APR for the 15-year mortgage is only 2%. So, and we're only doing that for ourselves. We don't need to do a 15-year mortgage for the high school grad. So we're going to once again use the PV function. Our interest rate for this 15-year mortgage is going to be 2%. To get the monthly interest rate, we'll divide by 12. The number of payments that we're going to make, we are doing monthly payments for 15 years. So 12 times 15 will be the number of payments. And the amount of the payment, we're again using 20% of our income. That's the 1389.83 value that we computed before. All right, so we're going to be able to afford a $216,000 mortgage if we go with the 15-year variety. Now again, there are some other computations there involving interest that you don't need to do in Excel. So we're not going to do those here. In prompt number 4, we start talking about retirement. And first we need to find a monthly contribution. In the 2019 fall project, we're going to save 6% of our income each month. And so for ourselves, we'll do 6%. 6% of our monthly income. So 6% times 6949.17. So we're going to put in $416.95. And then for the high school grad, we'll take 6% of their income. Again, not to beat a dead horse, but these computations are ones that you can do on your calculator. 6% of $2,000. The high school grad will be saving $120 a month. The project description gives us a retirement APR, and we're saving for 22 years. To find the retirement account balance, we need to use the FV function. The monthly interest rate, if we take the 7.99% APR that we were given, percent divided by 12. That's the interest rate for the first argument. The second argument, the number of payments that we're going to make. We're going to be making monthly deposits or contributions to this retirement account for 22 years. And the amount of each deposit then is a negative number. That's the one that we just computed above, $416.95. So after 22 years, we'll have saved close to $300,000. Doing something similar for the high school student, again using the FV function, taking our APR and dividing by 12 to get a monthly interest rate, 12 times 22 for the number of deposits that we're going to make here, and then the high school graduate is putting in $120 a month. All right, so they'll have saved up about $86,000. So that's writing prompt number 5. Again, there's some comparisons that need to be made there. In prompt number 6, we're trying to hit a couple of targets here, $100,000 and $200,000. And that's where we're going to have to, I'm just going to go ahead and copy this function. That's the first fancy thing I've done all day. I'm going to copy that function too. All right. And then we just need to go change the time that we're saving until we hit $100,000. So instead of 22 years, I guess we've got way more than $100,000 for 22 years. So maybe if I go for 10 years, 10 years is not enough. Change the 10 to 15 maybe. 15 years is too much. Maybe go for 12 years. 12 years seems to be a good amount. I think 11 years will probably be too little. Yeah, 11 years is too little. And you can get as fine as you want here. Maybe 11 and a half years is better. 11 and a half years is not enough. 11.75, that's 11 years and 9 months. 11 years and 9 months doesn't seem like it's going to be enough, so maybe we'll just stick with our 12 years. That's the best number that we found. You can go, there is a fancier way to get some monthly things in. I wouldn't, if you're gonna get finer than like every 3 months, which that gives you the 11 and a half and 11.25 and 11.75. If you're going to use any other decimal numbers, you should try to find the decimal numbers that correspond to months. Because again, we're making monthly deposits here. So if you're going to find it to the nearest month, that's the way that you should go. Well, we're going to go to the nearest year here and say 12 years. And then we'll do a similar thing to save up $200,000. Again, this is guess and check. It looks like 22 years is too much. We just did 12 years, so maybe halfway in between. Maybe halfway in between 22 and 12, that's 17 years. 17 years is not enough. 18 years is not enough. 19 years looks like it's going to get the job done. All right, so the need to save for 19 years. Again, if you want to try 18 and a half to get a little bit closer to the actual value, let's go with 18 and a half here. All right, 18 and a half years for ourselves to save up $200,000. And we're going to repeat that process for the high school grad. Again, we're changing the number of years. That's the 22 here. The high school grad has to save for longer, so maybe they got to go up to 30 years. 30 years is way too much, so let's back it off a little bit. 30 years down to 25 years. 25 years is too much. Go down to 23 years. That's not enough. 24 years. And I'm guessing if we go 23 and a half, that's not going to be enough either. All right, so let's just go back to 24 years. Again, if you want to get a little bit closer and find it to the nearest month, that's probably what I would do. If I were doing this project, I would find this to the nearest month. Because who wants to work a month longer than they have to, right? Okay, then for the time to 200,000, I think 30 years got us up to like 175. Is that right? Yeah. So we're going to have to go a little bit longer. Maybe 35 years. That's too much. Back way off to, let's just go 31 years and then 32 years. All right. This one might work for 31 and a half. Yeah, 31 and a half years is close enough. There. All right. So again, to hit these goals, we took our original parameters here, and we just changed, instead of going with 22 years, we changed the number of years. So in prompt number 6, you're changing the amount of time that you're saving. For prompt number 7, we want to change the monthly contribution. We're still saving for 22 years at 7.99%. We want to change the monthly contribution to try to hit $1 million just for ourselves. So I'm just going to copy down my FV function, and then I'm going to go in and tinker with the monthly contribution. So $400 isn't nearly enough. $400 a month gets us up to 300,000. Maybe if I go up to $1,000 a month, that's still not enough. So maybe we'll take it up to $1,500 a month. That is still not enough. Sorry, that's more than enough. Sorry, $1,500 was more than enough. So let's back off. Go down to maybe $1,300 a month. That's not quite enough. So we'll go up to $1,400. That's enough. If you want to stop at $1,400, I guess that's your business, but I might try to get a little bit finer. So maybe $1,350. Not quite enough. $1,375. not quite enough. Maybe go up to 1390. That's still not quite enough. 1395. I should have stopped while I was ahead there. 1398. All right, 1398 is good. 1397 is not enough. So maybe 1397.50 is more than enough. And we're just, this one's easier to get down to the nearest cent. 1325 is more than enough. Go down to 1315 maybe. That's more than enough. Again, we're just guessing a check and we're changing the contribution until we hit our $1 million kind of right on the nose. All right, let's see. 08, that's enough. 07, that's enough. 06, that's enough. So 6 cents was enough. 13.97 and 6 cents was enough. 13.97 and 5 cents was not enough. So it looks like we got to save up each month $1,397.06 if we want to hit $1 million after 22 years. All right, again, these are just the bare bones Excel work that we need to do. There are quite a few more computations, several comparison computations that you need to do with the values that you found. So please make sure that you understand the comparisons and computations that you need to do in addition to the ones that we've done in Excel here. And if you have any questions about those, please ask. That'll do it for this video.